Okay, so this is the 2004 AP Chemistry free response question for number 6. And it's an electrochemical cell is constructed with an open switch as shown in the diagram above. A strip of SN and a strip of an unknown metal, X, are used as electrodes. When the switch is closed, the mass of the SN electrode increases. The half reactions are shown below. So for A, it's asking us to label the electrode that is the cathode, and this is the half reaction for SN, and we know that in the equation it tells us that the mass of the SN electrode increases, which means that it's going to be on the product side. And based on the half reaction, we can tell that the SN ion is gaining electrons, which means it's the cathode, so SN is going to be the cathode. So for question B, it's asking us to draw an arrow indicating the direction of the electron flow in the external circuit when the switch is closed. And in A, we found out that the cathode is SN, and the electrons always will flow from the anode to the cathode. So the electrons will flow from metal X all the way over to SN. In question C, it says, if the standard cell potential, E cell, is positive 0.6 volts, what is the standard reduction potential in volts for the unknown metal electrode? So this is the equation to find the standard cell potential. And it told us that the standard cell potential is going to be 0.6 volts. And then we know that the standard cell potential for the SN electrode or the cathode is negative 0.014 volts. And then so we're going to solve for X, which is the anode. So for question D, it's asking us to identify the metal X. And in question C, we found out that the standard potential for the unknown metal was negative 0.74. So we just look on our purple sheet right here, and we find that negative 0.74 is Cr. So Cr is going to be the unknown metal. So for part E, it's asking us to write a balanced net ionic equation for the overall chemical reaction that occurred in the cell. And down here we have written the half reactions that were given to us. So now we have to flip the Cr equation since we know that that's the anode. And then we have to balance the two half reactions to allow the electrons to cancel out. So we're using 6 electrons overall. And then they will be canceled out, and the total, or the balanced net ionic equation is going to be 2Cr plus 3SN plus 2 yields to 3SN plus 2Cr plus 3. So question F has 2 sections, and in it, the concentrations of the ions are changed, which means that we're going to have to use the Nernst equation. And part 1 of question F is just asking us to substitute all of the appropriate values for determining the cell potential. And we wrote down the equation for the cell potential, which is right here. So now we just have to substitute in. And we don't know what the cell potential is of the new equation with the new concentrations, but we know that the E cell potential is 0.74 or 0.6 minus 0.0592 over N, which is the moles of electrons, which was 6, and then times the log of Q. And Q is going to be the concentrations of the new ions. And remember to raise them to their correct powers. So for the second part of question F, it's asking us that based on our response for the first part of question F, what will the cell potential be greater than, less than, or equal to the original cell potential? So we have written down here that Q the value of Q. And since Q is going to be less than 1, we know that the log of Q is going to be a negative number. And then whenever you're subtracting a negative, you're going to get a positive. Therefore, the E cell is going to be greater than the original E cell standard potential.